This is the video record for probability and stochastic process homework 5, question number 1. The problem setting is that we are given two independent variables x and y with its probability density functions as fx of x equal to unit function of x minus 1 minus u of x minus 2, and fy of y is equal to u of y minus u of y minus 1. And we are given z is equal to x plus 1, and we are supposed to find the fz of z, which is like the probability density function, by the following two ways. The first is the convolution method, and the second is geometric method. So in the first question, by the convolution approach, we first write the equation out to be fz of z is equal to fx of z convolution multiplies by fy of z, which is equal to an integral from the minus infinity to infinity of fx of alpha times fy of z minus alpha, and we take derivative of and we are is related to alpha. And so we first when we try to analyze the problem, we can see that fx of x and fy of y have like a one unit shift in these two equations. So we first try to find out the fz1 of z, where z is equal to x plus 1, for the case where the probability density function fx1 of x is equal to ux minus 1. And then by shifting the whole total result to the right side by 1 unit, we can get the fz of z, which the question originally asks for. And by applying fx1 of x, we use the convolution method to calculate fz of z, which is listed here. As we can see, the equation can be written as the integral of these two different equations multiplied together. The first is u of alpha minus u of alpha minus 1, and the second is u of z minus alpha minus u of z minus alpha minus 1. And these two can be calculated by separating the integrals, and finally get it to be z times u of z minus 1 times u of z minus 1 minus z of z minus 1 times u of z minus 1 plus z minus 2 times u of z minus 2. And these two can be combined together. And so for when the fx1 is equal to u of x minus 1 minus u of x minus 2, we just shift the whole result, in this equation, by 1 to the right hand side. So by substituting z with z minus 1, we can get the final result to be z minus 1 times u of z minus 1 minus 2 times z minus 2 times u of z minus 2, and while plus z minus 3 times u of z minus 3. And in the second question, we use the geometric approach to find the problem. And similarly, we have to first determine the result when when the probability density function of x is fx1 of x, which is in this case. And so we divide into different situations, where the first is where z is less than or equal to 1, and as the graph suggests, the distribution function for z is equal to the probability of z, where z is less than or equal to z. And so in which case it's the area of the shaded area in this graph, and it's supposed to be z squared over 2, and we can get the probability density function for this distribution function to be z equal to z. And in the next situation, where z is between 1 and 2, and it can be illustrated here, where the shaded area is also the distribution function of the probability of z, and it can be calculated to be minus z squared over 2 plus 2 times z minus 1, and the distribution probability density function is f of z equal to minus z plus 2. And when z is larger than 2, of course, there are no cross section with x plus y equal to z and the unit square where it's the value domain. So the distribution function for f of z is actually is actually the whole shaded area, or the whole area of the square, which is equal to 1, and the probability density function is absolutely 0. And by drawing the sketch, we get the PDF of all three situations, and it's supposed to be like this. And we just shift it by 1 unit to the right hand side, and we can get this is the sketch of the final result of the originally asked for the PDF of z, and we can rewrite this to be a function form or equation form, which is supposed to be f of z is equal to exactly the same as we get it from the first approach. This is the end of this first problem.